All right, guys, so this video is going to cover the notes for 7.3. In this video, you're going to learn about proving triangles similar. So to start off, what we're going to review is what did it mean to be similar, right? So looking at the top of our notes here, we can understand that similar triangles, these are going to have corresponding angles that are congruent, and we're going to have corresponding sides that are proportional. In the notes from 7.2, we had to show that all of the corresponding angles are congruent in order to say that the triangles are similar. Or we had to say that all of the corresponding sides are proportional. What we're going to look at today is three shortcuts that allow us to say that two triangles are similar. So the way we can prove that triangles are similar, the first method that we're going to look at is known as the angle-angle similarity theorem. So the thing to know about this one is that if you have two angles of one triangle congruent to two pairs of congruent angles of another triangle, then that information is enough for us to say that the triangles are similar then. So let's take a look here, right? If we look at the picture provided off to the right, we can see here that angle C has one ring. That is congruent to angle F, which has one ring. So we can write the following statement. Angle C is congruent to angle F. We can use that same logic for angle A. Angle A has two rings, and angle D has two rings. When they both have the matching amount of rings, that is understood to be congruent. So here we could say that angle A is congruent to angle D. And so what we'll realize here is, well, I got two pairs of congruent angles, right? So that takes care in red, our first pair of congruent angles, and now in blue, the second pair of congruent angles. This is almost like what we looked at last semester, like SSS, SAS, AAS, that kind of stuff. That proved triangles congruent. What we're looking at today is proving that triangles are similar. So if you can show that you have two pairs of angles that are congruent in two triangles, then that's enough information to say that the two figures are congruent. So we got two pairs of congruent angles, and we can now write a similarity statement. So we're going to write this in, and we're going to go ahead and choose the order here. I'm going to choose, for the triangle on the left, I'm going to write this as triangle CAB. Triangle CAB, and remember that this little symbol right here means similar. So our similarity statement would say triangle CAB is similar to, now we want to be careful because the order matters here, right? If I started with C, right? If I started with C here, C was this angle right here, marked with one ring. So that corresponds to the other angle marked with one ring in the second triangle. So I'd have to go with F to start. So it'd be triangle F. Next letter we have is A. A is the double ring. So that corresponds to the double ring here. So next letter would be D. So we got F, D, last letter here is E. So just make sure that you're being careful here. The order matters whenever you're writing the similarity statement. So just kind of slow down and just look at the angles kind of one at a time to make sure you put it in the correct order. All right, so just to summarize really quickly, if you have two pairs of congruent angles in two triangles, then we can say the triangles are similar. So let's look at some examples of what this could potentially look like. So if you guys look at what we have here down below, it's asking you here, can these triangles be proven similar by the angle-angle similarity theorem? If so, write a similarity statement. So let's start with the example here off to the left, right? I see here that this angle has one ring, this angle has one ring. This angle has two rings, this angle has two rings. What I'm checking for here is, can I prove this by angle-angle? Well, yeah, we sure can, because look, I got the angles in yellow, that's one pair, and the angles in blue, that's a second pair. So I got two pairs of congruent angles. That means that, yes, these triangles are similar. So similar, and our similarity statement at the bottom, I'm going to do yellow, blue, and then the unmarked angle. So triangle XVW would be similar to, I did the order of, like I said, yellow, blue, and then the unmarked angle. So in the second triangle, this would be triangle TUS. All right, so we can see here, at least for this example, pretty easily that I got two pairs of congruent angles, so it's similar by angle-angle. Next, we're looking at the second example here, and what I'm seeing is, again, we're checking, are these similar by angle-angle? Let's take a look. I see here that angle G is congruent to angle D, so that takes care of one angle. And for us to be able to say that we have angle-angle similarity, I need another pair of angles that are congruent. Now, these angles are not always going to be marked for you. Sometimes it's going to be up to you to determine whether some angles are congruent or not. And what I notice here is that located at F, we have a pair of vertical angles. this angle here on the top would be congruent to this angle here, vertical to it. So that takes care of a second pair of congruent angles. That satisfies the criteria of angle, angle. I got two pairs of congruent angles. So the triangles here can be said to be similar. So similar, and now we write the similarity statement. Just be careful again when writing this. So kind of slow down, just do it one at a time. So here, I'm going to go ahead and start with my angle in green. I'm going to start with the triangle on the top. So triangle G. Next, I'm going to go with the angle marked in blue with two rings, F. And then my last letter here would be H. So triangle GFH, what would that be congruent to? Now, I'm not congruent, I'm sorry, but GFH would be similar to the triangle now in the bottom. Follow the same order. I started with the green angle, so I'm starting with D. Next we had blue, so F. And then lastly we have E, right? So sometimes color coding helps make sure that you put this in the correct order. Not saying you have to, just saying that sometimes it helps. And so next we're looking at the third example here, and we're checking to see, can these triangles be proven similar by the angle-angle similarity theorem? So what you'll notice here is now that one triangle is inside of the other. So what I suggest for these, because sometimes it can be a little confusing to look at the two triangles that we have in this picture. I have the large triangle in yellow, and then I have the smaller triangle here in blue, right? So what we're going to do is we're going to separate this out. I'm going to draw out the blue triangle right here. And then I'm going to draw out the yellow triangle, the large one, right here. Okay. And now I'm just going to go ahead and label these. All right. So we got in the yellow triangle, the big one, we got this right angle located here. And this is GCE. The triangle in blue, I got another right angle here. So I got triangle FDE. Right? And so these are a little bit tricky because it's not super obvious, but take a look at what we have here. Look at this angle here, angle G. It's 90 degrees. Isn't this also 90 degrees? So if I'm looking at angle, angle, trying to determine, do I have angle, angle? Well, I got one pair of angles that are both 90, so those are congruent in green. The one that's not super obvious now is the one that we're about to mark right now. Take a look at this angle, angle E. Angle E right there, that actually is the exact same angle right here. Look at the two triangles in the picture right here. Can you see that this angle right here is shared by both triangles, right? So that angle E is shared between both triangles. Well, that angle is going to be congruent to itself. So separating out the triangles, we can see that, hey, this angle E right here is going to be congruent to this angle E right here. So that takes care of our second pair of congruent angles. With that being said, we now can say that, yes, these triangles are similar. All we have to do now is write this similarity statement. So I'm going to start here just using the same colors that I started with. Green is what I did first. So I'm going to do the yellow triangle to start. Triangle G, then my orange angle E, and then my last angle C. So triangle GEC would be similar to, in the blue triangle, this would be triangle FED. And so again, just make sure that when you are writing this part right here, please make sure that you are paying attention to the order. The order does matter. And again, this part that we just wrote, that is called a similarity statement. That is this right here, a similarity statement. All right. So let's go ahead and jump ahead to the next part of the notes here. Now, what we're looking at is example 2. It says, given the triangles are similar by the angle-angle similarity theorem, solve for the following missing pieces. So reading this example, it says that the triangles are similar by angle-angle. So we already know that they're similar. I'm not testing this, we already know. And so they give us some information here. They tell you here that the measure of angle E is 45, so this is 45 degrees. The measure of angle N, let's do this in a different color. The measure of angle N is 10x, so N is 10x. And the measure of angle L is 35. So L is 35. All right, so the question below is asking us, well, we want to find x and we want to find the measure of angle C. All right, so we're focusing our attention on this part right here. The triangles are similar. At the beginning of the notes, we said if the triangles are similar, then that means the corresponding angles have to be congruent, right? So in other words, what we mean by that is this angle here, if this is 45, this here must also be 45, right? Because they're both marked congruent. So that would be 45 degrees. You write that 5 a little nicer there. Similarly over here, I can kind of go ahead and start to match this up, right? So if angle L, if this has 2 rings in purple, then that means that it's congruent to this one here, 2 rings in purple. So this would be 35 degrees. And then lastly, our angle 10x, angle N right here, how it's not marked, well, that's going to correspond to this one. So this one would also be 10x. Right, so that's us filling in all the missing information in both triangles. Now we can begin to go ahead and start answering the questions below. How would I find x? Well, I know all of the angles in the triangle, right? What do the angles in a triangle add up to? We know that the angles in a triangle add up to 180 degrees. So I can write my equation as 45 plus 35 plus 10x is equal to 180. From here, you're going to solve for x, right? We should be comfortable doing this by now. 45 plus 35 gives us 80. 80 plus 10x is equal to 180. Next step here would be to subtract 80. Doing so gives you 10x is equal to 100. If I divide by 10, you get that x is equal to, well, 100 divided by 10 is 10. So x is equal to 10, right? Now the question was asking you for the next part, which is asking you for find the measure of angle C, right? If I want to find the measure of angle C, well, it's right here. Angle C is represented by 10x. So the measure of angle C, if it's 10 times x, we just found out that x is 10. So plug it in. This will be 10 times 10, telling you that the measure of angle C would be, well, 10 times 10 gives us 100. So the measure of angle C is 100 degrees. And that finishes up that example. Now let's take a look at the next similarity theorem we have. What is another way that we can show that two triangles are similar? And believe it or not, you already did this yesterday. We just didn't call it side, side, side. So if we scroll down here, we're looking at the next way we can prove that two triangles are similar is by using the side, side, side similarity theorem. This theorem states that if the corresponding side lengths of two triangles are all proportional, then the triangles are similar, right? Remember the word proportional. The word proportional means that the ratios are equal. So in this case here, right, if we have the following, right, so if I have, and we're just going to match this up here, right, AB with RS, BC with ST, CA with TR, if those corresponding sides, when you set them up as a ratio, if they end up giving you the same value, if they're all equal, then that means that they're proportional. And if they're proportional, then that means that they are similar by SSS, if all three sides are proportional, that is. Okay, so if I want to write a similarity statement here, it's up to you on how we want to write this. I'm going to start with just, let's do triangle ABC. Triangle ABC, I started here with A. So in the second triangle, I need to start with the one that corresponds to that. What corresponds to A? Well, A is joining the yellow and orange. Yellow and orange is R. So this would be R. And then similarly here, B would be the next letter that we wrote. B meets up with orange and blue. So S is orange and blue. That's what corresponds. And then we only got one letter left here, so T. Again, I know I'm going through this slow and I know it looks pretty obvious here, but just be careful. This is easy to make a silly mistake on. So our similarity statement would be triangle ABC is similar to triangle RST. So again, this is side, side, side. If all three sides are proportional, then that means that the triangles are similar. So let's go ahead and look at an example of what this looks like. So it says here that to prove side, side, side similarity theorem, their similarity ratios must be consistent for all sides. What we mean by this is that if I start with the triangle on the left, so let's say, for example, I start with triangle STU. So I start with this triangle here, and I'm putting those numbers on top. You need to do that for all your ratios. And then over here, let's say that I'm looking at triangle XWV. We're going to want to just be consistent. What we mean by that, again, is keep the same order, right? And so we did this yesterday. We actually did something very, very similar to this. So if I take a look here, we're going to label our sides in the red triangle. 3 is the smallest, 4 is the medium, 5 is the largest. In the green triangle, smallest is 9, medium is 12, largest is 15, right? So the ratios that you set up here, you're going to do, essentially what we're doing is we're going to write small over small, medium over medium, large over large. Okay, now we're going to focus on those numbers here. So small over small, notice that right here, we're saying that we're putting the numbers from the red triangle on top. So I'm going to put the number from the red triangle on top for my small over small. This is going to give me 3 over 9. Medium over medium would be 4 over 12. Large over large would be 5 over 15, right? So this is what we mean by keep the same order. Notice that all of my numbers on the top here are coming from this triangle, right? I'm keeping that order consistent there. So now what we're checking for is we've got our ratio set up. We need to check, are these sides proportional, right? And what I want to bring your attention to here so that there's not any confusion, I mean, I can do this on my notes right here. You can't, but please understand that the symbols right here, like this doesn't really need to be there. I'm whiting this out. But you need to understand here that these should not be congruent symbols. These should be equal signs. So we're checking right now, are these ratios equal? Well, let's simplify, right? Again, as a reminder, if you're not sure how to simplify, you can always do this with the calculator. If I look at 3 over 9, that simplifies to 1 over 3. 4 over 12 also gives us 1 over 3. 5 over 15, 1 over 3. So what you'll notice here is that, look, all of these ratios are equal. So that tells us two things. That tells us that, well, that means that all of my sides are proportional. And if they're proportional, then that means that the triangles are similar. If all of my sides are proportional, then it's similar. And in this case, similar by SSS, right? I have all 3 sides as ratios being proportional. All right, so example 2, let's just look at potentially, we'll try to do both here. If we see that this is taking a little bit too long, then we'll just do one of them. It says here for example 2, can these true triangles be proven similar by the side-side-side similarity theorem? If so, write a similarity statement. So we're checking, do I have side-side-side? All right. Here, what I'm checking is, are my corresponding sides proportional? So same idea. Let's go ahead and do what we did earlier, right? Small goes with small. These are my small. Medium goes with medium. And large goes with large. All right, so set up your ratios. Let's do small over small. And when the order is not specified, it's your choice, right? So some of you guys might be wondering right now, if I start with small, is it 3 over 9 or is it 9 over 3? It's totally your choice. You just have to be consistent. So whatever order you choose, make sure you keep that order the same. All right. So I typically just go from left to right. So I'm just going to do this as 3 over 9. That's my small over small. Medium over medium would be 4 over 12. Large over large would be 5 over 15. What we're going to look at now is we're going to simplify this, right? So if I simplify these fractions, what we'll notice here is that simplifying 3 over 9 gives me 1 over 3. 4 over 12 simplifies to 1 over 3. And 5 over 15 also simplifies to 1 over 3. So look, that means all 3 of these are equal. That means that all 3 of these sides are proportional. So that checks off the SSS. So these two triangles, they are similar by SSS. Now to write our similarity statement, here's where you're going to kind of want to be careful. Just kind of slow down a little bit. So if I'm going to have the freedom to choose how to start writing this, then what I'm going to do is I'm going to start with the letter, I'm just going to say QRS. QRS. So pay attention to where Q is located. Q connects what two colors? Q connects purple with red. Purple with red, I'm not sure what happened here. Maybe I didn't label it, but here are my colors labeled. This angle that connects purple with red here in the second triangle is L, right? So I would then start with L, right? Next, I'm looking at R. R connects purple and green. Purple and green connect at M. So next letter that I'm doing here would be M. And then lastly, I only have one letter left, so N. right? So just write the similarity statement carefully. That's all I ask, right? On a quiz or a test, we're always going to fill in this first part for you so that there is only one correct answer, all right? So we'll look at the next one, okay? We got the idea here. I'm going through this a little bit faster. Let's go ahead and label our sides here. Is this similar by SSS? Well, here is my smallest side here, medium, large. And the second triangle, small, medium, large. If I set up my ratios, I got small over small would be 29 over 7. Medium over medium is 39 over 9. And large over large would be 43 over 10. What you're going to notice is that these fractions, some of them might simplify, some of them might not. If you want to simplify 29 over 7, you can't. It's just going to stay as 29 over 7. 39 over 9, that actually simplifies to 13 over 3. And then 43 over 10, that just doesn't simplify. Okay. So as we look at these simplified fractions, are any of these equal? They're not. They're not equal, so this fails side, side, side. So these are not similar. So these are not similar. If they're not similar, I cannot fill this out because this is a similarity statement. You only write this statement when the triangles are similar. If they're not similar, you just leave them blank. All right, and so the last theorem, the last way that we're going to learn on how to prove that two triangles are similar is going to be known as SAS. So side angle side similarity theorem. For this theorem, we have this whenever we can see that an angle of one triangle is congruent to angle of a second triangle. That is the A part. And then if we have the lengths of the sides, including these angles, are proportional. That includes the S part. If we have that, then we can see that we have SAS, right? So in this case here, what we would be looking at is for side angle side, and this is a little bit messed up here in the notes, so we're going to fix this. But if I'm looking at SAS, the first thing I need to be able to see is, do I have a congruent angle, right? So is this angle Y, is it congruent to angle E? Well, yeah, they're congruent because they both measure 53 degrees. So we can start off by saying if angle Y is congruent to angle E, and here's where I know y'all can't white this out, but if you want to cross this out and write this off to the side, the only really thing that I guess we need to cross out here would be this. It's just the congruent symbol. That's what's throwing me off. This should say equal. So now what we're looking at, that takes care of, this is the angle part. Now we need to talk about the sides. The sides need to be positioned in such a way that the angle is in the middle. And we do see that here, right? So between the 6 and the 10, right, the smaller one would be this one. Let's do a different color here. Smaller one would be this one. The larger one's this one. In the second triangle between 9 and 15, this is my smaller, this is my larger. So let's do small over small. So 6 over 9 would have to be equal to 10 over 15, right? So we would need to be looking to see, hey, are my sides proportional, right? 6 over 9 simplifies to 2/3. 10 over 15 is 2/3, right? So that would now take care of our sides. So when you're looking at these theorems, we started with angle, AA. Then we did SSS. Now we got SAS. Please just remember, when you are checking for the S's, you're checking to see if the sides are proportional. Are those ratios equal? If you're looking at A for angles, you're checking to see, are the angles congruent? In this case, we have both conditions satisfied. The sides are proportional and the angle in between them are congruent between both triangles. If we have that, then we can write a triangle similarity statement. One way we can write this, we can just say triangle XYZ is congruent to triangle DEF. Now let's look at some examples utilizing to check to see, hey, is this side angle side, right? So we do have a typo here. Let's go ahead and fix this. In the directions here, it says, can these triangles be proven similar by, this should say SAS, because this is the section of the notes that we're looking at. Can it be proven by SAS? If so, write a similarity statement. So if we take a look here, this is what we're testing. Do we have SAS? Well, let's take a look here. Easiest thing to check for first is, well, do I got a congruent angle? Yes, we do. Not sure why it's being off like that, but we can see close enough here. So I got the angle taken care of. What I'm checking for now is, do we have the proportional sides, right? And is that angle in between two sides? Yes, the angle is in between two sides. That alone is not enough information to say that they're similar. We have to show that the sides are proportional, right? So let's set up these sides. If we look at these sides, right, between 2 and 3, 2 is the smaller one. So that's my smaller one. And I don't know why it's shifting down like that. 2 is my smaller one, and in the second triangle, 4 is the smaller one. So if I set up a ratio, this would be 2 over 4. The other ratio here, present, would end up being 3 over 6. So we're checking to see, are those sides proportional? What does 2 over 4 simplify to? Well, let's check. 2 over 4 actually just simplifies to 1 over 2. 3 over 6 also simplifies to 1 over 2. When those ratios are equal, then that satisfies, hey, I got two ratios that are equal. That takes care of my two sides. So we can say that, yes, these triangles are similar by SAS. Right? If I want to write the similarity statement, I'm just going to write it down here below because I ran out of room here. So my similarity statement, one way that we can write this is I'm going to start with the angle. So I got angle R, and I'm going to do RQS. Triangle RQS is similar to triangle. If I look at the triangle on the right, look at what we started with. We started with R. What corresponds to R? Well, they're both marked green, so F. Next, we're going from R to Q. That's my orange side. So from F to my orange side would be E in the second triangle. So F, E, G. So there is our triangle similarity statement. It got shifted down a little bit, but it is RQS is similar to triangle FEG. So let's look at the next example, right? So let's see if this one's going to end up being similar as well. So we're testing for SAS here, right? And if we're going to test for SAS, let's take a look at first, do I have that congruent angle in both triangles? We do. It's right. It's marked here with this one single ring here. Same thing here. So angle's taken care of. We're checking for the sides now, right? If I'm going to set these sides up, I think we understand the idea of how to set the ratios up, right? The smaller over the small, larger over the large. So when I set up the ratio here, what we're looking at is, well, the smaller one here in the first triangle is 13. So 13 over smaller one in the second triangle is 40. 13 over 40, we're checking to see, is that equal to my other ratio? Large over large would be 14 over 40. Now, if we simplify this, 13 over 40 does not simplify. It stays as 13 over 40. We're checking to see, is this going to be equal? It should be very clearly that it's not. 14 over 40 would simplify to 7 over 20. These fractions are not equal, so that means that it fails the S part of it. The S part is not proportional, so not similar. If they're not similar, you leave the similarity statement blank. And so that covers the three different ways that we can prove that two triangles are similar. You can do this by using SAS, SSS, or AA, right? Remember angles, the A's, to show that that is satisfied, the angles have to be congruent. To show that the sides are satisfied, the sides have to be proportional. And so we got some kind of word problems that we want to look at down here to finish off the notes. So here it says that similar figures can be used to find proportions. That involves using the properties of similar triangles to find the measure of heights, lengths, and distances that might be too great to be measured directly, right? So for example, if I told you to measure the height of our school and I wanted you to do it in centimeters, I mean, I'm not going to sit there with a ruler and measure it. I'm not. This is where we can use similar figures to our advantage. So let's look at an example. It says a flagpole casts a shadow that is 27 feet long. At the same time, a man who is 6 feet tall is standing nearby and casts a shadow that is 9 feet long. How tall is the flagpole? These word problems are going to make a lot more sense if we draw a picture. So I'm going to break this up into chunks. First thing that I see here is a flagpole casts a shadow that is 27 feet long. Doesn't have to be fancy, but here is my flagpole. If I'm casting a shadow, where's my shadow located? Shadows are always on the floor for the most part. So if my shadow for the flag is 27 feet long, then this bottom side here is 27, right? These types of problems, we're primarily looking at triangles. So I'm going to connect the top of the flagpole here to the end of the shadow, right? So here's my flagpole, and I have a shadow that is 27 feet long. Next, we're going to be talking about a man who is 6 feet tall. So let's draw the man here. Here's the man, right? So this man is 6 feet tall. Let me do this in a different color. This man is 6 feet tall, and he's standing nearby, and he casts a shadow that is 9 feet long. So what we're noticing here is that this situation creates two triangles, right? Now it's not directly stated, but we're going to assume here that these two triangles are similar, right? This appears like we're going to have a 90-degree angle here, 90-degree angle here, right? For these to be similar, I would need a little bit more information, but like I said, we're going to assume that these are similar. Now, what we're looking for here, as I read the rest of the question, so we did the man is 6 feet tall and casts a shadow that is 9 feet long, right? So I got that labeled. Question now is asking us to find out how tall is the flagpole. Here's my flagpole. The tall part here would be this. I don't know what it is, so I'm going to call it X, right? So drawing the pictures here helps tremendously because now that I have an understanding, if these triangles are similar, right, I'm just going to draw my similar symbol here. If these triangles are similar, then that means that the corresponding sides must be proportional, right? So that would mean that the height of the flagpole and the height of the man, that is a ratio that can be set up, right? So in other words, these two sides are corresponding. Similarly over here, the bottom sides of my triangles are corresponding. So I can set this up as a ratio of yellow over yellow is equal to blue over blue, right? So as we see how to set this up, I would be looking at yellow over yellow would be written as X over 6. Blue over blue would be written as 27 over 9. And what we can do now is we can solve by cross multiplying, right? If we cross multiply, we got 9 times x. Well, 9 times x is 9x. Then we have 6 times 27. That gives you 162. If we divide both sides by 9, we get that x is equal to 18, right? What I always tell my students is after you find x, reread the question. Make sure that you've answered the question. The question asks you, how tall is the flagpole? The flagpole is 18, but 18 what? You need to be specific. Look at the units in the problem. In the word question, 18 what? Inches, centimeters? In the word problem, you're going to see the word feet. So it's 18 feet. To answer the question, how tall is the flagpole? It is 18 feet tall, right? So to summarize for these word problems, please just draw a picture. When you draw a picture, it'll slowly start to come together. So let's look at one more example. The next example is very similar. It's actually the exact same, honestly. So I guess we can go ahead and call the notes here, right? If you wanted to try it on your own, you got some space down here to try it, but that'll conclude the video for today's notes. If you have any questions or you're still struggling with the material, again, as always, please just make sure to reach out to your teacher to schedule time to come in for tutorials. I'll see you guys in the next one.